Hello everyone, welcome to my YouTube channel. Today I am going to discuss about oxidation state, an important topic in chemistry, and this is useful for balancing equations and understanding redox reactions. So now let's look at what is oxidation state. Oxidation state is a positive or negative number assigned to an atom in a compound or ion to indicate its apparent charge. A positive or negative number assigned to an atom in a compound or ion to indicate its apparent charge. An atom having higher electronegativity is assigned a negative oxidation state. An atom having higher electronegativity is assigned a negative oxidation state. So let's look at what is electronegativity. The electronegativity is the tendency of an atom in a molecule to attract the shared pair of electrons towards itself. The tendency of an atom in a molecule to attract the shared pair of electrons towards itself. Here I have mentioned an important point. In molecules, more electronegative atoms gain electrons from less electronegative atoms. In molecules, more electronegative atoms gain electrons from less electronegative atoms. Now let's look at this hypothetical example, hypothetical molecule AB made up of A atom and B atom, and it has this single bond. Now this single bond has a shared electron pair. One is from A, one is from B, and this pair is shared each other, A and B. Now let's say A has 3.5 electronegativity and B has 1.0 electronegativity. Now A has the higher electronegativity. So A has that ability to attract the pair of electron towards itself. A has higher electronegativity so that A can attract the shared pair of electron towards itself. Now A has an extra electron. Therefore, we can say that oxidation state of A is -1. Now B has lost its electron. Therefore, we can say oxidation state of B is +1. Here is the electronegativity chart for S block elements and P block elements. I have mentioned the actual electronegative values. As you go from left side to right side, you can see that electronegative value is increased, and as you go from top to bottom, electronegative values are decreased. In this chart, fluorine has the highest electronegative value, which is 3.98, and the francium has the lowest electronegative value, which is 0.7. In order to determine the oxidation state of a atom in a compound, we have to follow a few rules. The first one is the sum of the oxidation numbers in a neutral compound is 0. The sum of the oxidation numbers in a neutral compound is 0. The second one is in an ion, the sum of oxidation number is equal to the net charge of the ion. The sum of oxidation number is equal to the net charge of the ion. And in compounds, group 1 elements we call as alkali metals have +1 oxidation state, and group 2 elements we call as alkaline earth metals have +2 oxidation state. Oxygen has -2 oxidation state except in peroxides, and hydrogen has +1 oxidation state except in hydrides. Fluorine in every compound, fluorine has -1 oxidation state, and group 13 elements have +3 oxidation state. Now let's look at this example H2O, water. This is the structure of the water molecule 2H and oxygen. I have mentioned the electronegative values for oxygen 3.44 and for hydrogen 2.2. Now you can see oxygen has the higher electronegative value. So considering this bond, oxygen, because of oxygen has the higher electronegative value, oxygen can attract both the electron pairs towards itself. Now hydrogen has lost its electron, therefore oxidation state of hydrogen is +1, and oxygen has gained one extra electron, therefore oxidation state is -1. Same applies for this bond as well. Oxygen has the higher electronegative value, so that oxygen can attract both electron pairs towards itself. Therefore, oxygen has one extra electron. And hydrogen has lost its electron. Therefore, oxidation state is +1. Now, oxidation state of oxygen is -1, -1, -2. According to our first rule, the sum of oxidation numbers in a neutral compound should be equal to 0. Now, H2O is a neutral compound, therefore oxidation number should be equal to 0. Now see, +1, +1 and -2 is equal to 0. Determine the oxidation state of chlorine in potassium chloride. Potassium chloride is neutral, therefore net charge 0. Oxidation state of potassium chloride equals to oxidation state of potassium plus oxidation state of chlorine. Oxidation state of potassium chloride 0. Oxidation state of potassium +1 because it is a group 1 element, and oxidation state of chlorine, let's say X. So 0 equals to +1 plus X. X is equal to -1. So oxidation state of chlorine in potassium chloride -1. I hope this will help you. Thanks for watching.